Hello everyone, welcome again to my channel. So today in this grid DFS series of videos, we will do another problem, that is 130 surrounded regions. So the problem statement is saying you will be given with one grid which will be filled with initially X and 0 or O. Okay. So what you have to do is you have to convert all this O as X and you have to return the grid. But whatever grid are at the boundary, from there, whatever connected grids are there which is also O, that you can't convert. That means here if you check, 0 is present here at the boundary. So we can't convert it. And if any other cell which is connected to 0 horizontally or vertically, that also we can't convert. So here if you check, this part is totally isolated from the boundary area because they are not connected horizontally or vertically. So this is one component, this is one component. If you remember the number of island problem, right? So this is one island and this is one island. So you can imagine like whatever islands are connected through this boundary, those we don't have to convert, and whatever has no connection with the outer cellular boundary, that we have to convert as X and we have to return. So if you take another example here, then it will be more clear. So here if you check, we have total 1, 2, 3, 4 areas which are 0. So this area if you check, this is connected with the outer boundary. This area also and this area also. But this area don't have any connection with the outer area. So we don't have to convert this part, only we have to convert this part. So the output it wants is this one. So this part we can't convert, this one on this one. As this has no connection to the outer world, we have to convert those zeros to X and we have to return that as an answer. So what approach you will take? So it's similar to all kind of DFS program. So where actually we have to start the DFS and we have to affect the areas which are connected horizontally or vertically. So now what we have to do in this case is, let's say we have to traverse all the cells using two for loop, right? As we are doing in the other problems also. Now we have to check where we can find our 0 which is in the boundary. So here if you check, if we start our like journey from here, we got the first cell which is 0 and it is in the boundary, right? So these are the boundary area. So from here we have to start a DFS call and we have to convert all these zeros to, let's say, another character, let's say P. Okay, so we have to convert it to P. Now we have to check in the fourth direction that where else we can go. Okay, means where else it is 0 is present. So we can come to this cell and convert it to P, and gradually we will convert it to P. Simple DFS approach to affect any connected cells, which we have applied in number of island problem and all, right? So all these things are converted to P. Now when we came here, this is also 0, but this is not a boundary cell, right? Because this is inside, so we don't have to do anything. Now we have to scan through, and we have to search another boundary cell if it is present, which is 0. So we got another one here. So we have to convert it to P using our DFS. And the DFS call will remain here only because we can't go anywhere else because all the areas are X or out of the boundary. Now here also we got another cell which is 0 and this is present in the boundary. So we have to convert it to P, right? So after one successful DFS call to each and every cell, we will able to convert all those zeros to P which are connected through boundary, right? Now next what we have to do is we have to scan the array again, means the grid again, and we have to convert this P to O, okay? And whatever zeros are there, that we have to convert to X, then only we are done. So first time we are marking all those cells which are connected to boundary, that we are getting using P, right? So as we don't have to change it, that's why we will make this P again to 0, and as we have to affect only these zeros which are inside the cell boundary, means which are not connected outside, so we will do a 0, we will convert to X, then only we will get our answer here. So these two things we have to do. We have to start our DFS from boundary cells and convert this 0 to P if they are connected, and that way whatever inside that will not get converted, and then at last convert P to O. So whatever P is present here, that we have to convert as O or 0, and 0 to X. So this 0 we have to convert to X, then only we will get our result. Now we'll see the coding. Now if you check the code here, the code is also simple. So whatever I have told, that only we have to declare here. So first we are getting the board or the grid. So we have to take the like row or column length from out of it, and we can assign it to a global variable because that will be helpful in our DFS, or else we can pass it also. Now we got the grid, and that we have defined here because that also you can access in the DFS recursion calls, right? So what we are doing first is, so we are visiting all the cells and we are checking if it is present in the boundary or not. How we are checking? We are checking if I equal to 0 or m minus 1 or j equal to 0 or j equal to n minus 1. That means they are present in the boundary or not. If in the boundary I got any cell which is 0, then we have to start a DFS call from there. So we are passing the I and j value from there and starting a DFS call to make all these zeros to P. So here is the DFS call, simple DFS call which we have already used in all this series of videos. So there we have to check first the condition that it is going out of the boundary or not. Okay, because from this cell when we will again do some DFS calls, so left side call will go out of boundary, right? So we have to stop there. Or else what we are doing, we are again checking if the cell is X or P. Means if it is X, so that direction we will not go, and if it is P, that means it is already visited, right? So that time also you have to return. And if it is not the case, then we have to simply make that cell as P, means visited from the boundary, and we have to call DFS in 4 direction: top, like bottom, left and right. Okay, and recursively it will make all these connected cells as P, right? So this is a common technique we used all these videos in this series. Now after this call, what will happen, all the boundary connected zeros will be converted to P, and if some cells are inside present which is not connected to boundary, which are 0, will be remain as 0 only. So next our job is to make those P again as 0, because those cells we don't want to affect, and all the zeros to X, then only we are done. Here we don't have to return anything because the answer they want is only the board. So as we are converting all these things or doing the operations on this board itself, so it will be like pass by reference kind of thing, or so they are using this cell and they can read from here. So we don't have to return anything, and the test case will be passed from there. So as we submitted, it is working. Thanks for watching.